Another Milwaukee repair. Now I got this off someone. It's an M12 Impact Driver, and the chap said it just smelled of burning from the back of it. So whether or not we can repair it's another thing. So I think what we'll do, we'll take it apart, get into it, and see what the damage is, and hopefully see if we can repair it. Right, so I'm going to start by, I think I'll remove the screws on this side first because there's only 3, and then remove the screws on the other side. Let's see if I can get the screwdriver in for all the stuff that's in the screw heads. Right, so one's removed out that side. Tell you what we should do first, we should put a battery in and just see what it does first. When the light comes on. And it did briefly spin there for a second. And now it's coming up with an error. Let's just try that again. And now nothing. And this is a brushless one as well, so I've got a feeling I'm probably going to find burnt MOSFETs. Let's take the screws out this side then. Seems quite a bit of concrete or whatever all around the place as well. Right, can we get into it now then? There's normally a clip at the bottom here, but that's missing as well. Oof. Right, let's zoom down a bit. Right, well, I can see signs of corrosion and things straight away. There's obviously a lot of corrosion around this part of the motor here. And it looks like there's some corrosion around about here as well. I'm not sure whether that's a blown MOSFET or something possibly down there. I wonder if I can get these bits out. Right, so that's the little display board down there that shows the battery indicator. But that looks sort of plastic welded in place. That must be the switch for forward and reverse. Get the button out of the way. And yeah, it definitely looks like we've got a blown MOSFET there. Right. I think what I'll do first, I'll get, because I don't know if I can get this apart anymore. Does that unplug? Right, that's on a plug. I wonder if I can unplug this and try and get this separated from the casing. Let's have a look. Is there another plug at this side? Yes. Right, I'll get that casing out of the way. Now can we get this motor assembly off? Normally they just slide out. But on this one it doesn't appear that it wants to. There's not a lot of room on those wires either. Right, I think I'll try and get some IP on some of this and see if we can clean this board off a bit, I think, because yeah, it's a bit dirty, let's say. Right, I'm just going to try and brush most of the light stuff off first with a little paintbrush, I think. Right, I'm going to try a little bit IP on there now, see if we can get a bit cleaner. Well, it's a little bit cleaner. It's just a pity I can't get this gearbox off somehow.
A few moments later.
Right, figured it out. If you wiggle it a little bit, and it comes out like that. Right, I'll get that bit out of the way now, so I've got a bit more access to it. Looks like we've got a microcontroller here. I think I might have to bring the microscope in on this one. Right, I'll do that. I've got it under the microscope here. And this is the main chip here, which is a integrated motor, driver and CPU all in one. I've seen quite a few of the Milwaukee tools use a similar chip. Now what happens is if the MOSFETs blow, sometimes they send power back down into this chip and it fries the driver part of it. So the CPU still works, so what you'll find is the tool will actually light up when you press the button, but it'll not go around properly or intermittently or whatever, because the chip's being damaged. And these chips get hot as well when they're damaged. So hopefully that's not the case, but if it is, well, we'll not be able to repair it. Because I think I had trouble even finding any information on these chips, was the first thing. And they also contain firmware, which is proprietary to Milwaukee, so we'd need to obtain the firmware, and most of the chips are read protected these days, so you can't just read the firmware out of them. Alright, let's continue looking over this board, see if we can see anything. And that bit of metal there is it's like a heatsink on the back of the board. Right, let's flip this board over and we'll have a look at this side. So that's where the microcontroller is. And that's the direction switch. That's the main switch in the way there. Let's see if I can just pull that out of the way for now. And then we'll get onto the MOSFETs, which actually drive the brushless motor. Let's try and get these wires out of the way a second. And that's the one that's blown. Looks like there might be a bit of damage to the board there as well. Right, I think what we need to do first then, we'll see if we can remove this blown MOSFET here and see what damage is to the board. Right, I'll set the rework station up. I've removed the heatsink plate from the back of this. That was screwed on with the screw holes just there, just to so it just doesn't absorb all the heat, and hopefully it's easier to try and remove this. Yeah, I think those two bits there are actually legs off the MOSFET that are welded to the copper tracks. Oh, got one off. Part of the track came with it. Yeah, it's the leg of the MOSFET there. Yeah, I don't think that's going to come off. Yep, thought that would happen. Right, let's try cleaning this up. Now by the look of it, it looks like all of the pads, or all of the legs on this side are linked together. Possibly not that end one. I'm just trying to see properly here. I think that might be a pad on its own. But these three here definitely look linked together. So what I'm thinking is we might just be to put a bit of copper tape over this area here. Hold it down with a bit PCB mask. And I think that should do to repair that. Just going to get my little grinding pen here. I'm just going to try and clean up some of this area a little bit. Yeah, so obviously all those ones are connected together, so they're probably either the source or the drain, and that's either the source or the drain as well. And that pin there is the gate pin, which is the one that tells the MOSFET to send the power from there to there or from there to there. Right, I think what we'll need to do as well is probably check this MOSFET here, because they normally work together in pairs. So if this one's blown, there's a chance it may have damaged this MOSFET as well. We've got a short on the gate pin there. And see if I measure that one next to it. That seems fine. And that seems fine. So yeah, there's a direct short. I'll try from there to the gate, see if we got anything. No, but we definitely seem to have a short from there to there. So I'm going to remove this MOSFET next, and hopefully that'll be easier to remove. Right, so I'm just going to add a bit of flux just around here first. And we'll get the hot air going on it. So there's the two MOSFETs removed, and it's easier to measure it just by turning it over, because you can get to the pins easier. So I'm just going to flip this over. So that's the gate pin just at this side here. So if I measure from there to there, you can see we've got a short. So yeah, so that MOSFET's definitely blown. The other one that was exploded, you can see there's actually legs missing off it as well. I don't know whether I can zoom in a bit further, you'll be able to see there. Yeah, so there's the 3 legs missing off this one, which welded themselves to the PCB. And if I just zoom out a touch there, and measure from the gate to here. You can see that that one's almost short. And this one's dead short. Right, so we need at least 2 MOSFETs for this. And we need to do a little bit of a repair on the PCB here. And hopefully it hasn't backfed and fried the controller chip. Right, so I'll order some MOSFETs and we'll continue the video when they arrive. The new parts have arrived. Right, I'll just zoom down a little bit here. And what I've done, I've put a little bit of this copper tape just across here, and I'm just going to solder it onto here first, tin it. I'm going to tin all these pads as well. We'll put a bit of flux on, and then we'll get these 2 MOSFETs on. So I'm just going to apply a little bit of flux here first. And then we're going to apply a little bit leaded solder. Yeah, I had a feeling that was going to happen. Let's see if we can just get that back in place. Right, I think that probably do. Let's put a little bit more flux on that top pad there. Right, I think that should do for that one. Let's move on to the other one. And again, I'm just going to tin these pads up first, just with a little bit leaded solder. Right, I'm just going to give it a bit of a clean up with some IPA and a cotton bud. I think I'm just going to add a little bit of solder to this corner. Right. Now we've got some solder mask, so I think I'll put a bit of solder mask on that bit there. It's green, but it'll do the job. Now we'll just get some UV light on that. Watch your eyes. Just to make the UV mask go off or go hard. I think it's better to add a bit of heat as well, if I remember right. Right, okay, happy with that. So I'm going to fit this little heatsink back on first. Just goes on the back here. It's held in place just with a couple of Phillips screws. Get rid of this blue tack now. Right, so how did this go back together then? Right, some that. Once this small plug went in there, this side. Oh, why isn't this going in? So I'm sure that clip goes in there like that. Right, there was the switch for the direction needs to go in as well, doesn't it? That's the only problem after you've it's been a week or a couple of weeks since you've took some apart. It's figuring out how it goes back together again. Right, I think that looks about right. Let's see if we can get the rest of the cover on. Right, let's pop a battery in and see what it does. I don't think the battery connector's lined up properly. Ah, that's why. I may just be able to get it from here. Right, now let's see if the motor driver chip's blown. Well, that's not looking too good, is it? Right, let's have another look. Right, so I've got it apart again, and I thought I'd just trace back from the MOSFETs just to see if they go straight to this chip here. And 3 of them do, but 3 of them don't. 3 of them go through these 510 ohm resistors here. And I'll show you what I've discovered. So if I measure this resistor here, we've got 505.8, which, you know, it's about right. Let's measure the next one down. Again, 505.2. And we'll measure this one down here. Oh, look. 1.7 mega ohms. And this is what drives the gate of the MOSFET. So I'm going to change this resistor and then we'll try it again, and hopefully it works, and hopefully it hasn't gone back and backfed into this microcontroller and blown it. Right, so after a bit hunting around, I've found a replacement resistor. I'm just going to put a little bit of flux on there and we'll get the rework station out. So I've just applied a little bit leaded solder to that. And we'll just heat that up a bit. Right, let's check the resistance of that now then. Right, that's better. And we'll check the next one. There's a bit of a coating on this board, so it's quite tricky to get the probes on. There we go, and I'll just double check the top one there. Right, let's try that again then. Right, let's see what it does now then. Fingers crossed. Yes, I think that's it. Let's try the other way. The trigger's a bit sticky. That's it. Oh, I'm glad about that. Let's have had this thing apart and back together and apart and back together, God knows how many times. So yeah, 2 blown MOSFETs and a resistor back up and running. I think we'll give it a quick test in some wood just to make sure that it's working properly, and then we'll finish off. Right, let's give it a real test then. And get the switch unjammed. There we go. Well, it seemed to work. Right, all seems to be working fine now. Well, if you enjoyed this video, please give it a thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.